So here we have a ladder, toy ladder attached vertically, and basically each of the lines represents the top of the next rung. It helps here probably to count these out. 1, 2, 3, 4, 5. A is the fifth one, 6, 7, 8, 9, 10, 11. And B is the 11th one. Because this is, even though it's not necessarily to scale, you know, this is representing, A represents the fifth rung on the ladder, B the 11th. Okay, so we're wondering how far from the ground is the top of B? And basically what we need then is to figure out what each one of these spaces on the diagram represents and multiply that times 11, or figure out some other proportion thereof. Statement 1 tells us that the top of A is 1/2 of a foot above the ground. So if this is 1/2 of a foot, then one rung of the ladder is 1/5 of 1/2 of a foot, or 1/10 of a foot. So if each rung is 1/10 of a foot, B is 11/10 of a foot above the ground. So there we have the distance of B. Statement 1 is sufficient. So we can get rid of B on its own, as well as the insufficient statements. Let's take a look at statement 2. The top of B is 3/5 of a foot above the top of A. So that tells us that this distance is 3/5 of a foot. However, we do know how many rungs there are between the two. So 1, 2, 3, 4, 5, 6. There are 6 divisions here. So the distance of a single rung would be 3/5, would be 1/6 of the 3/5 of a foot distance. We could cancel out this, and it equals 1/10, which we knew already, but you know, if we had done statement 2 first, we wouldn't have already known that. So one rung is 1/10 of a foot, and B being 11 rungs up is 11/10. So again, statement 2 is sufficient. Either one on its own then is sufficient.